Hello friends, we are a 5-member team from Semester 4 Computer Science Pandit Deendayal Energy University. This video is to represent a website designed as a part of group project for Operating System Lab demonstrating page replacement algorithms under the guidance of Dr. Rutviz Javeri. Let us view the website. Our website has been developed using React.js, Material UI and Tailwind CSS and deployed using AWS Amplify services. This is the home page, which gives us the introduction to page replacement algorithms. Let us understand the use of these algorithms. So when a page fault occurs, the required page has to be brought from secondary memory. But if all the frames of main memory are already occupied, then a page has to be replaced. Here, page replacement algorithms are required. Using this Go to Simulator button, we can move to the simulator page where we can implement different algorithms. Then moving back to the home page, following are the definitions of page, frame, paging and page fault. Then these are the 4 algorithms explained using this website that are FCFS, OPR, LRU and MRU. To know more about these algorithms, we can navigate to the blog section by clicking on Learn More. In the blog page, we have described the algorithms working. So first is FCFS, that is first come first serve. According to its name, the page which is assigned the frame first will be replaced first. To understand this, we have an example here. Here, the red lines represent page fault and the blue lines represent page hit. And this is the reference string of the pages. As we can see here, when the page 2 appears, we need to fetch it from secondary memory since it is not already present in the frames. So page replacement takes place and the page which was assigned the frame first, that is page 7, will be replaced. Similarly, other page replacements will take place. Also, we have Bilardi's anomaly in FCFS. That is, ideally we understand that increasing the number of frames will decrease the page faults, but according to Bilardi's anomaly, if we increase the number of frames, page faults increases. To understand this in a better way, we have a simulator. So let us move to simulator using the simulator button in navigation bar. Here, in the simulator, we need to enter the number of frames and the page sequence. If we add a negative value of number of frames like -5 and implement algorithm, it shows the message that frames cannot be negative. So now let us enter a valid example. For example, if we take the number of frames 3 and the page sequence as this, and by clicking FCFS we can see how it works. In the table here, the page faults are highlighted in red color and the page hits are highlighted using green color. Then the -1 value which we can see here shows that the frame has not been assigned to any page yet. Then in the summary section, we get the info about total number of frames, total number of pages, the page sequence entered and number of page hits and page faults. Also, a pie chart is displayed to have a comparison of hits versus faults. For the entered sequence, we have 25% hits and 75% of page faults. Also, the number of pages is described besides the percentage. Here we can also simulate the same example to understand Bilardi's anomaly. Let us increase the number of frames from 3 to 4 and see. Now here we can see that by increasing the number of frames from 3 to 4 in FCFS, the number of page faults increases from 9 to 10. That is, percentage increases from 75% to 83.3%. Here we can also simulate the same example for different algorithms by clicking on the respective buttons of OPR, LRU and MRU. Also, we can reset the data using reset button. Now let us understand the working of OPR, that is optimal page replacement. Optimal page replacement algorithm replaces the page which will not be referred for so long in future. But this is practically impossible. Why? Because we cannot predict the future string. It does not suffer Bilardi's anomaly since it follows stack property. Here is an example of optimal page replacement. So, in the given reference string, when page number 2 occurs, it replaces page 7. Why? Because the occurrence of page 7 is not there in the future string. Then when page 0 occurs, there is a page hit. But when page 3 occurs, it replaces page 1. Why? Again, because out of already present pages, the page 1 is referred at last as compared to page 0 and page 2. Let us see the simulation of OPR. So taking the number of frames as 3 and the page sequence as this, let us implement OPR. Following are the results of OPR, where page hits are 7 and page faults are 8. That is 53.3% fault and 46.7% hit. Now let us understand LRU and MRU. LRU, that is least recently used, and MRU, that is most recently used. LRU replaces the least recently used pages, that is the page which has not been referred for a long time. And MRU means most recently used. It replaces the page which has been referred most recently. Both the algorithms, that is LRU and MRU, follows stack property, so they do not suffer Bilardi's anomaly. Let us see the example for LRU. Here, in the given reference string, when page 3 occurs, it replaces page 1. Why? Because 1 is the least recently used page. Similarly, in MRU, when page 3 occurs, it replaces page 0. Again, because 0 is the most recently used page, that is used before 3. To see the simulation of LRU and MRU, let's move to the simulator. Taking a number of frames as suppose 5 and a random page sequence like this, let us implement LRU. These are the results for LRU. The number of page hits is 9, page faults 6. That is, the ratio of fault is 40% and ratio of hits is 60%. We can also implement the same data for MRU. So here are the results for MRU. Here the number of page hits is 6 and page faults are 9. That is, ratio of faults is 60%, ratio of hits is 40%. Now let us move to the About Us section. In the About Us section, one can get information about our executive team, their roles and their profiles. As an X factor, we have added the Contact Us section in our website. Here, using this, one can share the reviews or concerns regarding the site as well as contact us. Here you need to enter your name, your email address and your message. Suppose, for example, let us enter some random data like test, some random email address and a random message and submit it. Now, moving on to our Firebase. This is the project overview we can see, and in the Firestore database section, we can see the data obtained from the website. Here are some data from the past like this. And here is the data that we just entered. We hope you understood the description of the website and the project. Thank you.